Okay, now we're dealing with graphs of absolute values with inequalities. The inequality part is much less work than the line, okay? So first problem, y is less than or equal to 3, absolute value x plus 2. Now remember, the parent function for an absolute value is simply y equals absolute value x. So if I put 0 in for x, that's 0. If I put 1 inside an absolute value, it's 1. If I put negative 1, that's still 1. 2, 2, negative 2, 2. It's a V shape, okay? But we have to make a translation. So we have A, H, and there's no K, okay? We have to deal with the H first, okay? So the 2. If it's an H value, it's right. It's translated right horizontally, right, left. But it's opposite. Since it says plus 2, we have to go back the other way. So all I have to do is translate that down for left 2. Okay, so negative 2, 0 is my new vertex. Goes from here to here. Now, 3 is the stretch. Okay, remember how you graph a stretch on an absolute value. We put a 1 under it. That's up 3, 1 to the right. And then up 3, 1 to the left. So it stretches it. 1, 2, 3 right, 1, 2, 3 left. 1, 2, 3 right, 1, 2, 3 left. And it's going to be a symmetrical V, same as it was before. Now, you're like, well, how do I do the greater than, less than? And you need to make the V so it goes all the way to the end of the graph. You don't have to really do the true false, because a V, it's not hard to see, okay? This is above. Above it would be greater than. Below it would be less than, okay? Below it would be less than. Well, we have a less than, okay? By the way, I made it solid because the equals are. If the equals weren't there, I'd have made it dashed, okay? Well, this is less than, okay? So less than, we're going to shade beneath it. So that means you shade the whole outside. Anything outside that V here. And you're always going to do that. Above it's greater, below it's less. Once you start shading below, you'll come to the realization, well, that'd be everything outside. Okay. Next one. Y greater than or equal to x minus 4, absolute value plus 5. Okay, there's no A. That's good. Okay, and the parent function, get that down. Okay, no A, just H and K. So translate. When I'm thinking of what I have to do to translate, I work backwards. So 5, that's a K value. That's up, down. So that would be up. 4, that's an H value. That goes left to right. Now minus is this way, but it goes the other way on an H. Okay. So I have to move that vertex so it's up 5, right 4. 1, 2, 3, 4, 5, right 1, 2, 3, 4. Or you could go right 4, up 5. It's the same thing. So 4, 5 is the new vertex. Okay. Now there's no stretch. There's no A. Okay. So that means we just do the 1 to 1. 1, 1, 1. Because A actually has a value of 1. I'm not going to put it there, but it'd be 1 over 1. Basically, it's the same as that. Okay, now again, greater than, less than. What sign do we have? Well, we got greater than. So greater than, I shade above. So it's just basically everything inside of the V. Okay, so a much smaller solution set for that. Okay, Y greater than negative 4/3. Absolute value x plus 3 plus 7. So my parent function of an absolute value is the V, 1 to 1. Now we got to translate. First we're going to translate the vertex, okay? A, H, and K. So let's look at my K. 7, that's up, down. Since it's plus, we're going up 7. 3, okay? Right, left. Now it's plus 3. We think of that to the right, but it's the opposite inside. When you get inside the grouping symbol, it's opposite. So we're going the opposite of plus 3. So I take that vertex point and move it up 7, 1, 2, 3, 4, 5, 6, 7, up, and then left 1, 2, 3. So it's going to be -3, 7. Now, -4/3, that's the stretch. So you're going down in both directions, but you're going right on one side, left on the other. So down 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Do it again. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Okay. Now don't forget you have to shade it. Still, even though it's upside down, above the vertex is greater, below is less. That does not change. Okay. So we have greater than. Oh, I made a mistake. The line should have been dashed. The V should have been dashed because the equals 2 is not there. I'm sorry. The line should have been dashed. Okay, so I see greater than, so that's up here. So there's all my true points. That means the whole outside is true. Make that so it goes all the way down to the end of the graph. So everything above. Okay, last one. Okay, so my parent now also get rid of that equals 2 sign. I want that out of the problem. Don't do it on your own, but I'm changing the problem, okay? Because I want to actually do one correctly. Okay, so A, H, K. Now it's time to translate. K, I got 4. That's up or down. Well, since it's minus, we're going down. 5, that's right, left. It says -5, but we do the opposite, which is +5. Okay. Remember, here I'll even put this -4 would be to down, but then a -5 we would switch that to 5 forward. Okay, switch that. So now you get ready for the vertex. Okay, you're going to have to account for your 2/3, but we can do the vertex with just the H and the K. I would do that after I did this. Okay. So I'm going down 4, 1, 2, 3, 4, and 5 to the right. 1, 2, 3, 4, 5. So that is 5, -4. Now we have to stretch it. So 2/3 is the stretch. Remember how to stretch an absolute value. Similar to a slope, so that's the rise, but then we run to the right and we run to the left from the vertex. So up 1, 2 over 1, 2, 3. Up 2, 1, 2, 3. Can't do it from that side. 1, 2, 1, 2, 3. Okay. Now I'm going to make it dash because I took away the equal, so that's a dash. Because everything on the actual V is the equals part. Any points on the line make one side equal the other, and it doesn't say equals. So greater than, less than. Greater than above, less than below. That doesn't change no matter if it's right side up or upside down. Greater than, less than. Greater than, less than. Okay? So it says less than. So true. So that's all these points outside of the V.